Perfect. Can everyone hear us? Cool. So my name is Florian. I'm a researcher at Florin Digital. We're a liquid fund. And then in the last couple of months, we've been spending a lot of time looking into coprocessors. We have a dedicated Telegram group for coprocessor enthusiasts. We have a meetup tomorrow. And we have been writing around 100 pages about the topic. So it's great to moderate the panel today. So before we go into introduction, can every one of you give me a 30-second definition of what a coprocessor actually is?
Do I have to start?
There we go.
All right. To me, a coprocessor is like a secondary engine, like a secondary processor that you can outsource computation from like a main chain. Could be on any layer, but from a main chain. But really, the important part and the way I think it kind of differs from like oracles and other things is that it kind of inherits or needs to be at the same level of trust assumptions as the host chain that it's connected to.
Perfect.
First, I'm a little distracted because I'm looking at the pictures of us together, and it looks like we could be like brothers or something like that. So my mind's a little preoccupied. But yeah, what's a coprocessor? So I think very simply, a coprocessor is some system that moves compute off of the base layer 1. I think it's sort of a word with two meanings, though. We often use it as a shortcut to describe a stateless coprocessor. So there's like the superset of all coprocessors would include rollups and L2s and other scaling solutions. But then there's stateless coprocessors, which perform like atomic execution off-chain, either via consensus or verifiable compute. And yeah, so I think we're really talking here mostly about stateless coprocessors. Yeah.
Yeah. Mo?
Yeah, so for me, coprocessor is a component that enables the kind of computation that is fundamentally not possible to do on smart contract and blockchain virtual machine systems through a asynchronous design pattern. So basically, you have the access to very, very powerful and even highly parallel type of computation power that is just not available today on blockchain via this kind of asynchronous call and callback design pattern via coprocessors.
Okay, perfect. So we internally define coprocessors as stateless, verifiable off-chain compute. So I think when we look at the three panelists today, you're building three coprocessors, but they're quite different. Could you maybe, let's give it a bit of more time than 30 seconds, maybe like a minute or two, to explain how your coprocessor is unique and how it really works? We can start with Mo, if you want, Guy.
Yeah, sure. So yeah, what Brevis does is Brevis is first of all, we are working on the general field of off-chain verifiable computing, but our initial focus is very much to allow smart contract to have a trust-free access to on-chain historical data and do arbitrary computation on top of them. So imagine now you will be able to directly in your smart contract access users' historical behavior such as transactions, swaps, what is the user's historical token holding balances, and all this information will now be able to become available in your smart contract. You can do computation on them, and the result will also be available in your smart contract without relying on any third-party trust. That is like the trust assumption still that you only trust the blockchain itself. We're able to do this because we use ZK technology underlying to generate an end-to-end secure proof showing that these data you want to do computation on and the computation itself are all correctly accessed and computed on. So that's what Brevis does. And we are trying to not only just build specific things, but a very generic framework where users and developers can actually access these kind of off-chain computation resources. So, in addition to this pure ZK model that we already have, we also have an optimistic co-processing model where instead of doing every computation in ZK, you can do an optimistic proposal on the blockchain via things like TEE, via things like proof of stake systems such as eigenlayer AVS to say, okay, this is the co-processing result, but at the same time having a last line of defense in terms of security by using a ZK fraud proof. So this is something that is very unique for Brevis, and this is something that actually helped us a lot in the go-to-market process when we are partnering with many of the biggest DeFi projects.
Awesome. Risc Zero. Your turn.
Awesome, yeah. And I forgot to introduce myself. I'm Brett Carter. I lead product at Risc Zero. And that's a good segue. So we're building much lower in the stack. Like our focus is making ZK accessible to developers. So basically, like we wrote one circuit that looks like a CPU so that you can just write general purpose programs that inherit the characteristics of ZK. You don't have to write circuits to use our ZK VM. And so, yeah, we really have built like a ZK stack. So we built our own proof system, like innovated a new prime field that's becoming very popular called Baby Bear. Our proof system is like Stark-based, quite different than the Starkware folks, but very similar and based off of the original Stark paper. And then we built this ZK VM circuit and a recursion circuit on top of that like result in this general purpose ZK VM. And that general purpose ZK VM has some really powerful components when it's applied to like a coprocessor setting. So number one, like because we're a focused layer in the stack, like we're building a ZK VM that all of you can use. It's open source. And so rollups can use it, other coprocessors can use it, et cetera. But like one of the interesting characteristics about that that's inherited from our proof system is we have this feature in our proof system called continuations. And so if you build a coprocessor with our ZK VM, you get literally boundless computation. So there's no limit on the amount of computation you can do based off of like constraint sizes. If you're familiar with ZK systems, there's often like some max number of constraints or some max number of cycles that you can prove. Our proof system really does this very magical thing where if you write like a really long program in Rust, we just automatically chunk it up into like equal sized parts, and then we can, using our recursion primitive, sort of stitch those parts together. And so you can really just like generate a proof in perpetuity. Just as like a really fun, dumb example, we ran Doom in our ZK VM, including the rendering. So you could literally play Doom verifiably in our ZK VM. So that's like just a really dumb example. So I think the boundless computation is a really key component
It's not dumb,
there.
it's an awesome example.
Yeah, it's a good.
It was awesome. When I saw it, it was like mind-blowing.
Yeah, yeah. Like we had to do some fancy things around like parallelizing the prover. You know, we make these chunks, we can parallelize it. Required like we can do a full megahertz of proving once you or more, really like 10 megahertz of proving today. And so the boundless computation thing is really, really attractive because you can literally take, for example, like an FHE library, plop it into like just literally pull down a crate for FHE, plop it into our ZK VM. There's a team in the audience here that has done this, the Hashcloak team. And you can literally run FHE like in our ZK VM, which is a really powerful combination. And so that boundless compute is sort of first thought as a unique identifier. We've also built on top of that a little bit of developer tooling, and I'll shut up here in just a second. But just like to make it even easier, particularly for Ethereum and EVM developers, to use our ZK VM. So we recently released a library called Steel. You can find it. It's Risc Zero -Ethereum. It's in the Steel directory. And it's a really powerful coprocessor library. There's no vendor lock-in, right? You're not like stuck to an AVS or you're not stuck in some particular service. You can just deploy it yourself, run the prover. And what it does is it allows you to make a verifiable view calls into the state of Ethereum. And so what does that mean? You can literally just like query the state of any given contract at any point in time and then compute over that state. And you can query many contracts at the same time. So for example, we've run, using this boundless characteristic, we've run over 100,000 S loads in a single proof. We can go higher than that. There's a couple inefficiencies in dependent libraries that we need to work out, but 100,000 S loads for reference is I think like 210 million gas. So we've literally done in an individual proof 7 full Ethereum blocks of execution, like very simply in a for loop. So just very, very powerful primitive. So Steel will also let you query contracts and call your Solidity functions. You can literally write your ZK functionality in Solidity, deploy it on chain, and very simply call it. If you get to that repo, there's like a 12-line example of how to prove the balance of an Ethereum or of an ERC20 token. It's like just so dead simple. So like no more storage proofs, writing elaborate circuits to do all these sorts of things. Just makes it super easy.
Perfect. Guy.
Yeah, so I think we're taking a different approach. Like our goal is obviously not to build like a lower level like ZK proving or anything like that. And also we're not doing it necessarily for scalability, we're doing it for confidentiality. We want to allow, like, whether like you're on a chain or a rollup, wherever you are, you have your dApp, and you need to do some computation over like private data, like encrypted data, then we want to allow you to do it. Now, at Fhenix, I mean, we're developing this layer 2, where people can come and deploy their dApps, but we've come to realize that in many cases, like, we don't want to ask people to move their dApps or just deploy them like on our L2. Like, we want to meet them where they are. Like, if they're like on the Ethereum L1, on Optimism, their own rollup, on an Orbit chain, doesn't matter. Like, we just want to give them the ability to do some computation on encrypted data where they need it. Like, I don't know, there's a DAO on Arbitrum, Orbichain, and they want to do private voting. So there's no reason for them to move everything that they do to us. They can just leave their application on Arbitrum, and then they can interact with our coprocessor and do like private voting. So that's really kind of like the motivation of what we're building. And underneath it all is the FHE, that's the technology we're using in order to compute over encrypted data.
So see, I think this is very interesting because you're offering a stateful but also a stateless solution, right? You're offering a L2 and a coprocessor.
Right, so the L2 is like stateful, and you can build like fully fledged apps, and obviously there's benefits there. But yeah, if you're using like the coprocessor model, then it's stateless by definition.
Awesome. So quickly talking about the stateful versus stateless verifiable off-chain compute. When is Brevis and when is Risc Zero starting to add the state and become an L2? Or would you rather prefer to stay a coprocessor and not add state?
Yeah, I would say like layer 2 rollups and the coprocessor are fundamentally two different things. The rollups are trying to not only scale up the computation, but also at the same time states. And I would say mainly for states, actually, not really for computation. Because if you think about it, for rollups, the computation power is still very much limited. Because like the fastest compute you can do on a rollup cannot really exceed the capacity of a single sequencer, or like a group of sequencers if you're using decentralized sequencing system. So that's the cap of the type of computation you can do on rollups, and there is a fundamental limitation for that. You know, anything that is very complex or data heavy you want to run and you want to access in your smart contract, you really cannot do that in rollup. Anything that relates to AI inference, if you want to do inference directly on chain using verifiable compute, you simply cannot do that in rollups. But what you can do is to actually expand the type of computation you can access to using coprocessors. Because coprocessors in many cases are right now stateless, so you can actually branch out and start to grow a parallel computing ecosystem and parallel computing capability out of a single chain. That is, you can concurrently have multiple different coprocessors computing different type of tasks at the same time and post the result back to the blockchain asynchronously when the computation is done. So that's a perimeter that is very, very powerful. Now, if we really want to use state, can we do that? Yes, for sure. So in Brevis, we have also a continuation functionality that you can actually commit a bunch of intermediate computation states, and if you want to directly output that state into the blockchain, you can. But that's kind of that's just for cases where you want to temporarily store certain states and then pick up the state via it's more for interoperability use cases where you have one coprocessor computation that is running but want to relay the intermediary state from this computation to a different computation process. So that's how we see the states is going to play in the coprocessor space. Yeah.
Okay, perfect. Brett?
Yeah, as I mentioned, I guess I don't think of it as sort of a binary problem. It sort of depends on your use case. Like maybe you need to be on the layer 1 because you're chain link, right? And like people rely on your price feeds, or your Uniswap, that's where the liquidity is, and so like you have to be on the layer 1, in which case you can use ZK coprocessors to do a considerable amount of verifiable computation off-chain. In the ETH research forum, there's a developer that used our ZK VM, for example, just to sort of offload the execution of a swap. So obviously like the transaction ordering happened on the L1, but like just the execution was done via ZK proof, and so you're able to take really expensive gas and just generate a really cheap proof instead as a result of that. And so in those use cases, like maybe MakerDAO, I think oracles are actually like a really exciting and interesting use case for coprocessors. You sort of have to be on the layer 1, or you have to be on some particular chain, and you can't sort of create your own little environment that's stateful. That's generally where I think they'll be fit for these stateless coprocessors. At some point, applications maybe get big enough, they sort of produce enough gravity to like attract enough users and liquidity that sort of it justifies maybe becoming their own environment, their own L2. There's many applications that are using our ZK VM for that as well, but that's sort of how I think of the paradigm.
Okay, perfect. So we have 5 minutes left. I would love to talk about use cases, because when I'm talking with DeFi applications, when I'm talking with other applications, they really don't see the value of a coprocessor at the moment, because quite frankly, they don't care about verifiability. So I would love to understand from each of you, what's the really unique use case you're enabling? And this is less about DeFi incentives in a very trustless way, but what's the real one killer use case you're enabling in maybe 12 months or 5 years?
I won't be a bearer of maybe good news. Like, I know what I'm excited about, but I have not seen whether the market is excited about as well. I am very skeptical of anything like at the intersection between AI and crypto, because I think without verifiability and without confidentiality, it's like useless. Like, I don't feel comfortable all of the time like using ChatGPT with my private queries. So would I just use like a random provider or coprocessor, even if it's verifiable, to like run my query, and they see, and some random person sees all my data and can leak it? Probably not. Clearly, like, you know, there's scalability issues and the technology is not quite there. But like, I am really, really excited about like seeing how like confidential compute and AI using coprocessors can actually like improve what we do with smart contracts. And we have a few ideas about like what that could be. Like maybe it's like, you know, private credit scoring for better capital efficiency for DeFi, as simple as that. Maybe it's like, you know, proof of humanity and decentralized like KYC in a provable and a confidential way. But those are just on the drawing board right now, so we'll see.
Okay, perfect. Brett, what's the use case, the really one killer use case you and Risc Zero is excited about?
Oh man, it's funny because I made a list of use cases that's like a mile long. It's hard to pick one. You mentioned DeFi, and I failed to mention this in the last question, but like, you know, you need an L2 and you need like very low latency and lots of ordering, right? Like where ordering is really, you know, sensitive. One of the pitfalls of ZK today is it requires like a certain amount of latency. You can think of it like an async call out of a smart contract. And so like there's some time to like go get the proof. And so that does mean there's like a natural mismatch with DeFi. You know, that does like sort of add friction in terms of ZK adoption for DeFi. We released Steel. There's a couple teams that are like playing around with it. One of them that comes to mind is a DeFi team. So Tokamak is a yield optimizer. You can look at they have a repo called Risc Zero-demo. You can see how they're using our ZKVM. They have this thing called a stats contract, really a lot of solidity, like thousands of lines of solidity code to calculate trailing averages and understand your yields and how you can optimize them. And they're playing around with our ZKVM because it's really attractive for them to take all of that really expensive logic, write it once in Rust, and be able to update it off-chain while just sort of committing to the unique sort of, you know, ZKVM guest program, as we call it. There's a unique ID to the logic that they have off-chain. And they can use crates in our ZKVM. They can do, you know, linear regressions. Again, like no longer do the transaction size limits and the block size limits matter to them. So when you want to do some, you know, really big computation, something that would be way too expensive in gas, even repetitive tasks, signature aggregation is like really overlooked. We can verify thousands and thousands of signatures. You know, we can query thousands and thousands of contracts in the ZKVM, basically for free. It's very, very low cost. So if you're doing like really heavy compute, there's teams doing AI inference in our ZKVM. Lots of people in the Discord in the last week. So it's the very real use cases I think are in play for DeFi here quite soon.
Awesome. Mo, what's the unique use case you're looking forward to?
Yeah, I think fundamentally what ZK coprocessor enables, and especially for Brevis, we enable smart contract to have extremely high performance and low cost access to users' historical interactions on chain. And if you think about it in Web3 today, you know, there isn't really any paradigm or design pattern that allows smart contract to read that data and customize user behavior and customize their user experiences based on those data. But if you look at Web2 today, every single application you open on your iPhone, you know, has that type of functionality. It figures out what's the profile of a user and treat the user differently, handhold the user, engage the user, acquire new users. So if we want to expand the kind of people that we actually welcome into the entire decentralized application ecosystem, Web3 has to have that type of functionality as well. So, you know, this is something that we're very super excited about. And, with Brevis, you can actually access thousands and tens of thousands of data points with extremely low latency and use that to power your application in a data-driven way. Things like dynamic fee based on volatility for DAXs, things like trading volume-based discount, and all of that stuff will become possible using Brevis and ZK coprocessor in general.
Awesome, thank you. Just maybe closing words, 10 seconds. When you're building applications and you want to work with DeFi applications, please think about the actual ROI for the applications. Because one of the things we're seeing with coprocessors, a lot of customers, they don't see the use, they don't see the ROI, and I think it's our role to really show the ROI for that coprocessors offer for applications. Thank you.
Thank you.